Hi, everybody. Today is Friday, September 16th, 2022. I am man who got toothpaste in his eye this morning while brushing his teeth. And today we're going to work on more exorcism. Today I believe we're going to be talking about structs. Structs are an extension built on top of maps, which provide compile time checks and default values. A struct is named after the module it is defined in. To define a struct, use the def struct construct. That sounds funny. The construct usually immediately follows after the module definition. Def struct accepts either a list of atoms or for nil default values, or a keyword list for specified default values. The field without defaults must precede the fields with defaults. So in this case, we have a module called plane. We use def struct. It says engine and wings, and so engine will be nil and wings will be 2. Cool. Since structs are built on top of maps, we can use most map functions to get and manipulate values. The access behavior is not implemented for structs. It is recommended to use the static access operator, which is the dot, to access struct fields instead. So for example, you generate a plane value, and if you want to get its engine value, you do plane.engine, or you can use map.fetch, and that works as well. Similarly, if you want to update a value, you can use the map, standard map like update value pipe situation, where you say plane, and then you do pipe, and then wing :4, and that will change the wing value to a 4. Enforcing field value initialization. We can use the enforce keys module attribute with a list of the field keys to ensure that the values are initialized when the struct is created. If a key is not listed, its value will be nil as seen in the above example. If an enforced key is not initialized, an error is raised. So for example, if you create a struct called user and you enforce key username and you try to create a user struct value, and you don't supply a username, then you're going to get an argument error that forces that. And the other, thing I'll mention, if we're going to be talking about the concept here, is that a lot of people who see this and who come from like strictly typed languages will freak out because you're not defining like wings as an integer, or engine can be nil, and things of that nature. And that is like part of the dynamic nature of Elixir, in that like we don't enforce those types. There are ways to help get that with tools like Dialyzer and type specs, which we've done a little bit, I think, before. Let me look at the syllabus. What have we? Type spec. Yeah, we did do type spec back there. We didn't really talk about it a lot, but typically what you'll do in like a production environment is you'll write type specs on all your functions, and those will help kind of enforce some of the rules as you run tools like Dialyzer on top of your code base before compilation. So with all that said, we're going to be working on the remote control car exercise. In this exercise, you'll be playing around with a remote control car, which you finally saved enough money to buy. Cars start with full 100% batteries. Each time you drive the car using a remote control, it covers 20 meters and it drains 1% of the battery. The car's nickname is not known until the unit is created. The remote control car has a fancy LED display that shows 2 bits of information: the total distance it has driven, displayed as meters, the remaining battery charge displayed as battery. If the battery is at 0, you can't drive the car anymore, and the battery display will show battery empty. Okay. So let's download our example and open it up in VS Code. I actually had a bit of a moment this morning when my internet wasn't working, and I was shocked to find that I was able to fix it with a very simple power cycle. I don't know. I posted it on Twitter. I was like, I was ready for battle, but I didn't need to do a battle. It just kind of resolved itself. So, okay. So task one: implement remote control car.new to return a brand new remote controlled car struct. So, for example, okay. So we got to do our define struct. And it's going to be, what do we need? Nickname is none. And then, well, I guess we'll do battery. We'll keep it in alphabetical order. Battery percentage. We'll start off as 100. And distance driven in meters. We'll start at 0. And when I say alphabetical order, I pretty much mean the the format or remove the brackets. I pretty much just mean in the code base. In the runtime, the map keys will be kind of ordered up until a point. I believe the number is like 32 keys. Like after that, the order gets kind of completely thrown out, and the compiler will kind of remanage things. But just because you create a map with a certain ordered, a certain key presentation in the code, don't expect that's what it's always going to show up as. For example, like when you print it out in like a debug statement or something. Okay, so we now should be able to say remote control car, and we're going to need a % there. So we can run these tests maybe. Text required nickname. Oh, we need to do. Oh, I didn't read the second line here. The nickname is required by the struct. Make sure that a value is initialized in the new function, but not in the struct. Wait. The nickname is required by the struct. Make sure that a value is initialized in the new function, but not in the struct. Okay. So trying to figure out what they want me to do here. I think what they want me to do is to say nickname is nickname. And then if you call new without that, then it would just call new with none. And the style that they had here was just, yeah, so like you could, so we'll say nickname, and then those. Alright, let's run this again. No. No. Where's my test? Run at cursor. Remote control card name. Oh, they enforce keys. Nickname. Again, that right? Force keys username. It was never used. Kind of weird. I mean, that line is coming from force keys. You need enforce keys needs to be before def struct. Wow. Okay, that looks good. All right, let's run this other test because this is part of task 1 as well. That looks good. And then we've got this. So number 2, implement a new function to return a brand new remote controlled car struct with the provided nickname. Blue. I think we're doing that already. Yeah. Number 3, display the distance. Implement remote car display distance function to return the distance as displayed on the LED. For example, display car. Okay. So this just returns a string. So there's a couple ways you can do this. 0 meters. One way to do this is just to do an inline string, which is like remote car dot distance driven in meters. That'll probably work. I want to run all these tests because I wish there was a way. Can you run a test that just says like mix test and just pass in the tag that you want? I feel like you can do that, right? X unit. Mix test, test helper. Mix help test. Okay. Yeah, that I do all the time. Mix test help. Okay, I'm gonna skip that. I think you can external true. Mix test. Task ID 3. No, this is running everything. Alright, I'm gonna give that up for now. I don't know what. So we were working on task 3. I wish these were grouped with a describe. That would make my testing a lot easier. So this fails. are you testing? Displays distance raises error when not given a struct. So when you're given a map. I mean, okay. What did they tell us to do? I mean, the thing of it is like you can definitely pattern match for a struct in the argument. Implement display distance function to return the distance as displayed on the LED display. Make sure the function only accepts remote car struct as the argument. Okay. So the way I would do this would just be, I would say, I would put the struct in there, and then I'd say, and then I'd capture the element there, and then I'd, you know, and that should, yeah, that'll make it pass. Okay. So let's run this one and see if this works. That looks good. That looks good. Then we're up to number 4. So number 4 says, implement display battery function to return the battery percentages displayed on the thing. Make sure the function only accepts remote control. Remote control car. If the battery is at 0, then the battery will show battery empty. Okay. So yeah, one way to do this is again to capture that, and we'll say battery percentage, and the standard message is going to be what? Battery at percent. But then if you want, you can have a pattern matched version of this that says like when, you know, battery percentage is equal to 0, you can say battery empty. You could also do a, and this is where you kind of get into a type thing, like you can declare a type spec for the struct, and you can say that, like, you know, battery percentage is a non-negative integer, and that helps kind of enforce a little bit of type checking to verify that, like, you never set it to be a an invalid value there. So that works. That works. That works. And that works. So now we're up to number 5. Driving changes the battery and the distance driven. Implement a drive function that updates the number of meters driven by 20 and drains the battery by 1%. For example, if you were to give a new car and then you were to pass it to drive, then you expect the battery percentage to be 99, and there's that. Okay, do that. So we'll accept the remote car, and we'll pattern match it just for I don't know. We want to validate that we are actually getting that in. And then we could say new battery we'll say new battery percentage equals, and we'll say battery percentage minus 1, and then we'll say new distance equals distance plus 20, and then we'll return I guess we could just return this, like we could, yeah, we can build the struct. So we'll say remote control car, nickname is just going to be car time nickname, and then battery percentage. Battery percentage is new battery percentage, and then distance in meters is new distance in meters. We will need a capture here. So we'll say, like, so for example, if battery percentage, we can not capture that there. Oh, this is part 6. Yeah. Well, we're jumping ahead here. But we're gonna need that. Like, if the battery percentage is 0, and actually we can just pattern match on the value 0 itself here. Actually, we could do that there too. We don't need a when. We could just say, we can just pattern match on the absolute value there. So when it's 0, we just return the car. Can't do that. But when this happens, that'll do that. So, all right, let's start running some of these tests. Actually, we might actually have all the tests done. Let's just try running them all. All right, cool. That looks done. So the other way you could do this actually is, and they kind of showed us this in the concept doc, was you could say, you know, given this map value, update this key and update this key. That way you don't have to be explicit about setting the name again, because you don't really want to worry about that implementation detail. Yeah, that still works. All right, cool. Let's upload it, and we'll see what the analyzer has to say about our lovely work here. Use a default argument for new. Okay, I can do that. So instead of doing this, we could just say none. And we can get rid of that. And we'll validate that our test will pass. Then we'll re-upload it. And that looks good. Look at the community solutions. So they're using the underscore module keyword there. That's fine. I kind of like, I like writing the real module name here because I feel like it makes the code a lot more readable. I can appreciate the underscore module keyword, but I tend to only use that if I'm doing like metaprogramming or something where it's like really dynamic. If I can say the real thing, like for example, they use that there, but they don't use it there, so it's a little weird. I don't know. Other thing I don't like about our current solution, although they didn't ask us to fix it, is that they did not ask us to do the pluralization of meters. So you'll get this scenario of like 1 meters. Not in this logic, but technically you can get that. They do a case, that's valid. There's an argument to be made that this is actually better because it kind of collects the domain knowledge a little bit better, whereas this one, I don't know, pattern matching on 0 and doing it up here and then doing it up there. Because these are like 1-line returns, it almost makes better sense to have them in a case. I don't know. They do a similar thing with 0. They just return the remote car. And they do the mutation of they do the new value generation inline on the assignment, which I technically don't usually like because I like to kind of like describe the domain concept that's going on. And if you do it down here, you're really starting to overload these lines where like there's a lot going on, and I prefer to try to make it where there's not as much going on. But cool. So I'm pretty happy with that. We're going to mark it as done. We're going to publish our iterations, and we have learned structs. And we've unlocked 6 new concepts. We've unlocked 10 new exercises, and we will get to those another day. Cool. So with that, I want to thank you again for watching. If you have any questions or feedback, please do let me know. Other than that, have a nice weekend, and I'll see you next time. Bye-bye.